Okay, YouTube, in this video we're going to confront how to solve equations containing rational exponents. And what we're going to see a lot of the time is sometimes complicated radical expressions. And so what we need to recall is that we can actually say that a base to the power of m over n, for instance, would be the same thing as saying the nth root of that base. So we have the nth root of a here, where n is the denominator is the root. Okay, and we're raising that to the nth power, or we could also say that it's the nth root of a to the m. But either way you look at it, we say that this numerator in the rational exponent is the power. It's the power. And recall that the denominator is the root that we're taking of this. And so rewriting it as a rational exponent is kind of nice because we can actually solve these things pretty simply. So we'd say the following table shows the steps used when solving equations containing rational exponents. So we say solving radical equations of the form x to the m over n equal to k. We're going to assume that m and n are positive integers in lowest terms. That is, they share no common factors, but we also say that k is some real number here on the right side of this equation. If that's the case, basically what we're going to do is we're going to isolate the expression with the rational exponent, which, as you look at this right here, we would say that this x to the m over n, it is all by itself on the left-hand side of this equation. And then what we'll do is we'll raise both sides of the equation to the n over m power, or what we're going to do is exponentiate both sides. Exponentiate both sides, let's say by the reciprocal power. And the reason why we're going to do this is because when you raise both sides to a power, say for instance we say that I have x to the 1 over 2 is equal to 2. If I were to take both sides here and raise both sides to the 2 over 1 power, what you'll see is that when you take a power to a power, you multiply your exponents, and it's very true that anything times its reciprocal is always just 1. So if our goal here is to isolate this base, we want to get an exponent of 1 on it, and if that's the goal there, we're just going to raise both sides to the exponential reciprocal power. So when we look at letter A here and then letter B, we'll take a look at these. We say 5 times x to the 3 halves minus 25. We're going to isolate this base before we do anything else. So we'll go ahead and add 25 to both sides of this expression, or this equation here. So we would get 5x to the 3 halves power equal to 25. And then we'll go ahead and carry out our division here. We still need to isolate that base. So we say, getting the 5's out of the way. Now we have something that says x to the 3 halves power is equal to 5. And because we have this base to the rational exponent isolated now, what we'll do is we'll exponentiate both sides. So, sorry I'm using brackets on the left here. It doesn't really matter what you use. But we're going to raise both sides to the 2/3 power. And by doing this, we get x to the 1 is equal to 5 to the 2/3 power. So this is indeed our solution here. Now I will say that usually I would evaluate this if I could possibly do it mentally, but I don't know what the cube root of 5 is off the top of my head. So that being said, there is no rule that says we cannot just go grab our calculator and try to work for a solution here. So if I say 5 to the power of, now all in parentheses here, we're going to put this all in parentheses. Here we go. We say to the 2 divided by 3. We're going to find out as we get some decimal value about 2.924. And this would be easy to check back in the original equation. Now we won't get exactly 0 because we'll probably plug in a decimal approximation here, but it'll be really closely enough approximated. So I'm going to leave this here for now. We'll come back and talk about it. When we solve this one, let's go ahead and add 8 to this side. So we end up with x to the 2/3 on the left side by itself. We get 4 on the right. So now I'm going to take both sides and I'm going to exponentiate to the reciprocal power, which is 3 over 2. So I get 3 over 2 here. And what I notice is on the left, I get x to the 1. That's exactly what we wanted. Now on the right, I do actually know the square root of 4. So to evaluate 4 to the 3 halves, we always start with the root, or at least you should. We say this is the same thing as x equals 2 to the 3rd. And the reason why I mention this is because what we've just done is we've taken the square root of 4. Now the interesting thing about the square root is that when you take the square root of something, it's actually plus or minus. So now I have to say, well, x equals plus or minus 8 in this case when I take 2 to the 3rd power. So why does this happen? So the last comment I want to make on this video is essentially this. If we're going to raise both sides to the n over m power, so we say if m is even or m is odd, where m is this right here, the top of this right here, which means that when we exponentiate both sides, it'll be the denominator value on that exponent, that reciprocal exponent. The idea is this. If m is even, what we're saying is we're taking an even root. That would be something like a square root, a 4th root, a 6th root, so on and so forth. And what that means is we have to put a plus or minus out in front of this. And the reason why is because, well, whenever you take the even root of a number, it could be a positive or a negative result that does this for you. But if m is odd, that is, if we're taking an odd root, you will get one and only one solution. Okay? So here's what we're going to do. We're going to check these out in the original equations, but over here on the left, I noticed that I was taking a cube root, so I really just get a positive 5 to the 2/3, whatever that was. And over here, I get a plus or minus 8. So if we were to plug these back in, see if we get a solution here. I just want to look at the second equation. We had x to the 2/3 minus 8 is equal to negative 4. I need to make sure that both the positive and the negative 8 work. So plus or minus 8, question mark. So if I plug in now a positive 8 to the 2/3 minus 8 is negative 4. What we see is this. I would take the cube root of 8. The cube root of 8 is 2. So I still have to take 2 to the second minus 8 equals negative 4. And 2 to the second is 4 minus 8 equals negative 4. It does seem that we get negative 4 is equal to negative 4. And that checks out. So now when we go back up and we check out now negative 8 to the 2/3 minus 8 equals negative 4. What I should notice here is this. I take the cube root of negative 8 is actually negative 2. So I get negative 2, and we need to square that now. Minus 8 equals negative 4. Square that, I get 4 minus 8 is negative 4. So I get negative 4 is negative 4. So it actually checks out. Both of these work out. So being careful on how many answers you get depending upon whether you're taking an even or an odd root.